This is the angle sums and differences exercise. And in this, you're going to learn how to convert between sine 2x, sine 3x, sine 4x, cos 2, 3, 4x, etc. and what they are equal to in terms of their expansion. So you're going to see some expansions here. There's 6 expansion rules you're going to see here. I believe you've got 4 of those 6 on your formula sheet, and I'll show you as we go through. So here's the first one. Now, I've decided here that in the past I've gone through and done this proof, but generally it's gained me nothing except death stares and complaints, and it's not really that relevant. So I've decided not to give you the proof. I'm more than happy to give you the proof. I'm happy to go outside of class and record me going through the proof and doing it for you. I'm happy to build the proof with you in class if you want. We have got time, but the proof the proof in your textbook is something I've not really seen before. The proof that I usually would show you looks a bit like that. You've got to build that diagram with an alpha and a beta, and then you've got to extend lines out, and you've got to get into this triangle here, and you can prove it within that right angle triangle. It takes a while. There it is there, there it is there, there it is there, and we're all good. So I'm not going to show you that proof, but I've got the link to it on there, or page 442 on your textbook has a different variant on that proof, but it's still a full page proof. So I'm leaving it with you. But there's the first rule. We need one of these rules to be proven using one of those methods, and then we can use that rule to prove the rest. So we're going to start with cos of A plus B is equal to cos A cos B minus sin A sin B. And actually this is a trig identity, so technically I should be saying it's identical to. But you'll probably see that most of the time people write equal. And that was a question that came up the other day actually. Somebody was asking me about symbols to do with this. So if you have equals, that's a statement that's saying for that particular moment these two things are equal. You'll often say a variable equals a number. If you have 3 lines, then you're saying identical to. In this case, you're not saying for a particular moment, you're saying for any A and B, these two things are always equal. That's what an identity is. So and that's 3 lines. So you might say that sometimes. I don't know what's just happened there. Updating policy. That's good. I've always preferred proof 2, etc., etc. If you know that cos of A plus B equals cos A cos B minus sin A sin B, then you also know these following things. Cos A minus B is equal to cos of A plus negative B, and that's equal to cos A cos negative B minus sin A sin of negative B. Now, there's a little bit of a trick here. You need to know that cos of negative B is equal to cos of B, and that sin of negative B, can anybody guess what that's equal to?
Negative sin.
Oh, didn't fall into my trap. Well done. Negative sin of B. And this one here is called an even function. This occurs because that's symmetrical about the y-axis. If you draw the sketch, this one isn't symmetrical about the y-axis because it's on this side it's in a positive, on the other side it's in a negative, but it's got a rotational symmetry. That's an even function, that's an odd function. We'll go into that a little bit later. The easiest way to see it though, that you'll be used to, is the unit circle. Cast, and if I've got B and negative B, well, cos is positive in both, so they're equal, but sin of B is equal to negative sin of negative B, or the other way around. So the relationship there is that sin is negative in the 4th quadrant. So you get that slight difference. But I'm going to use that here to make the statement, therefore this is equal to cos A cos B, but now it's plus sin A sin B, because that's equal to negative sin B, negative and negative makes that a positive. So you've got now 2 identities. That's the one on your formula sheet. I don't think this one is, but it's really easy to remember. It's just if you've got a minus inside there, this becomes a plus. Just swaps the sign. Everything else is the same. Identity number 2, sine of A plus B. Well, that's equal to cos of pi on 2 minus A plus B, because we've got that relationship sine theta equals cos of 90, or pi on 2 minus theta. That's our reading off the vertical axes, or that relationship there. So we've got that relationship. I'm using it here. I'm changing where my buckets are. So I've expanded that negative out, which means the A is negative and the B is negative. And then I'm taking those two bits separately. And I'm now going to write it like this. I'm going to use the cos rule, my first cos rule, and that gives me that cos pi on 2 minus A times cos B. What is the rule? It's negative. No, is it negative? Oh, it's this one. It's this rule here. So I'm going to use the one directly above. So it's positive. Sine pi on 2 minus A cos sine B. Sorry, translation now is poor. And we know the same rule here. Cos of pi on 2 minus A is equal to sine of A. And sine of pi on 2 minus A is equal to cos of A for the same rule. And so I get sine A cos B plus cos A sine B. There's my expansion now. And you see they're all very similar, so you've got to be careful with that. The sine expansions have a sine and a cos and a cos and a sine, and the plus follows to a plus here, whereas the cos works a bit differently. Cos ends up with a cos and a cos and a sine and a sine, and the plus is going to turn into a negative, negative turn into a plus. You might guess what this one's going to be, but I'll prove it anyway. Sine of A minus B is equal to sine of A minus plus negative B, which is equal to sine A cos negative B plus cos A sine negative B. And we did this work earlier. That's equal to sine A and just cos B. And then this is now sine negative B is negative sine of B, so it becomes negative cos A sine B. Now I know you're excited because you know I told you there's 6 of these and I've only given you 4. So should we have a look at the other 2? Yeah. The good news is they're actually probably the easiest 2. Is it going to hurt anybody if I go to there? Okay, well, you're not writing it down, are you? So sine of 2A is just equal to sine A cos A plus cos A sine A, which of course is just equal to 2 sine A cos A. Bam. That's sine of 2A. And my last one, and I'll zoom out and let you copy it down in a second. Cos of 2A is cos A minus sine A, which of course is cos squared A minus sine squared A. And just as an aside to this one, you'll know that cos squared A plus sine squared A is equal to 1, which means that sine squared A is equal to 1 minus cos squared A, which leads to rule 5, part, I won't use capital, 5A, an extra little rule here which will come up, and that is that cos 2A, which is equal to this bit over here. Well, if I take the sine squared A out and put this in, I get it's equal to cos squared A minus 1 minus cos squared A, which is equal to 2 cos squared A minus 1. And 5B, for the same reason, but instead of taking out the sine squared A, I take out the cos squared A, I get cos 2A can also be written as 1 minus 2 sine squared A, for the same reason. So we've got these 2 little sub-rules that occur in rule number 5. I know that's a lot, but 4 of those rules, maybe someone wants to check, but I'm pretty sure 4 of those rules are on your formula sheet. And it's only rule number 1 and 3 that aren't. But they're really simple translations of rule 2 and 4. No. 1 and 3 aren't, of the original rule and 2. So here's my summary, and you can, if you want to copy stuff down, this is the one. So cos of A plus B is equal to cos A cos B minus sine A sine B. Cos of A minus B is cos A cos B plus sine A sine B. And cos 2A is equal to cos squared A minus sine squared A, and those other two variants. So plus 5A and plus 5B. Sine of A plus B is sine A cos B plus sine B cos A. And sine of A minus B is sine A cos B minus sine B cos A. And sine of 2A is 2 sine A cos A. So there they are in all their glory. And it's 10:23, so I'm actually not going to get through any examples. But just as a warning, fair warning, next lesson I've got example 1, 2 and 3 for you to do. But I'll leave this up for now and I'll finish it there.